Okay, so as I said, let me get closer so you see. So these are my panel that I use. So I use Blue Sun panel, a very good Chinese panel. It has served me well. It's almost about 5 years now since we installed it, and the output have been same. We don't have any problem. So let me just walk you through what the data sheet. So the model, that's the model number BSM. It's a 320 watt panel, 72 cells. Okay, and it's a mono cell, and it's 156 by 156 cell. Okay, the date of manufacture is what you can see here. Is 2027, and the data sheet is divided into two. So we have where the maximum operating power is, and we have the open circuit and short circuit voltage parameters on your right hand side. These are very important for your designing. Okay, so if you look at the other video, we'll go through how to use and interpret these ones. So for today, our use, it says it's a panel that is 320 watt panel. At maximum power, the voltage should be 37.5. That's what you should have, and the current should be 8.57. Okay, but at open circuit, where you have high resistance or where there's no load connected to the output of the panel, you can reach as high as 45.86 volts. At short circuit current, where there's zero resistance between the two terminals, you expect a current of maximum 8.99 amp to flow. So we should be very careful when we are sizing this panel, especially the open circuit voltage and the short circuit open circuit and short circuit current. These are very important. So the size is there, the maximum fusing size is there, the maximum system voltage that you are required to use because of IEC regulation is also there, the weight is there, which is 25 kilogram. The power tolerance is there, which is, I mean, maximum vary between maximum 3% of the output. Standard test condition was we use 1000 watts at every meter square at atmospheric pressure of 1.5 at 25 degrees Celsius. I mean, that's constant. I mean, it can operate under a temperature of minus 40 degrees to as high as 85 degrees. And the manufacturer warranty is 10 years. Okay. So what they're saying is that, look, at 15 years, your output will go up to 90%. And at 25%, 25 years, will go as low as 80%. I mean, I haven't gotten there yet, so I'm still enjoying what it is. So I'm going to decommission this panel. I've already brought it down from the roof. I'm going to align them in there. I'll pull only 3 or 4 of them, and we'll put them in series, and we simulate various conditions, see how the panel behaves, and see how we can identify if a panel is faulty. So this is the other one as well, which also have the same. In fact, all the panels are the same. They have the same rating, the same parameters. So we're going to do that and see how it looks like. Okay, good. These are not half cell panel because these were bought or purchased before the half cell technology kicked in. So let's get in. Let me leave them to arrange them on the ground to see how solar panel works. So the solar panel generates or converts the sun energy into electrical energy or electrons, and these electrons are connected or collected through the connecting leads, and they come out, and you can then use them for whatever electrical energy purposes you want to do. Okay, so there are two things that drives the power or energy generation on the solar panel. So one of them is the temperature. So your temperature that the panel rises determines your voltage. So the voltage is driven by the temperature. Okay, then your current is also determined by the irradiance from the sun that hits your panel. Okay, so these two factors are very important. But then remember, the panels are designed to work at a certain temperature. The more you go, because it has a temperature, negative temperature coefficient. What that means is that the more you go beyond the design temperature, then you are reducing the output of your generation. So even though temperature is okay, it's required for the solar to work, excessive temperature is also not too good for the panel. So without much ado, we'll do the experiment. So these are, I just put only 4 panels off from the roof, and let's see. So this panel is, let me see. So this is if you can see, this is a Blue Sun panel, which is rated 320 watt panel. Okay, so I've dropped it where I suspect it might have a problem, so I'm dropping it down again. Now the next panel is this one, which is also 3 should be the same brand. So this is also Bluesun 330 watts. Okay, this test is good when you deal with the same solar panel brand. So the next one is this panel, which is also the same 330, so 320 watts Bluesun panel. Okay, so we gently drop this panel. Then the last fourth panel is this panel, which is also the same Bluesun with the same electrical characteristics. Okay, so we gently drop this panel as well. Now I'll connect all of them in series, but again, before I start, let me also introduce you to how panels are designed or are connected electrically. So the black substance, this is a mono panel. Okay, this is not a poly, it is mono. Okay, so you identify the mono with this cut at the edge. I mean, usually it is circular for them to manage to be able to get it. So we'll discuss that in the next video so you understand how the mono is designed. Okay, so the basic form of identifier is this cut edge at the four corners of the mono. Okay, it usually comes in a circular form, but to get it in the square form, so we make use of the space, because it's already circular, we'll be losing a lot of areas. So assume you have one circle this way, one circle this way, one circle this way, then the space here will be bigger. So then when it comes to efficiency to the energy conversion, the space utilization will become highly inefficient. So these are the panels are designed. This cell is connected in series of this cell using these bars. Okay, connecting bars. So this cell is connected to that cell. This is connected to this one in series. This is connected to this one. So it's done in that fashion from beginning here to the end there. Then it is connected to the next row, that is this row. So this row is connected to this row. Okay, it comes down here, straight down here. Then there's a thick bar here. This bar now connects this cell to these cells, and it goes down straight to the end. At the end, it's also connected to the next row, and that is this row through a bar. When it gets here, this is connected to this one. It goes up to the end, return, and come back to here. So this is the final one. This goes to the junction box. The starting one also goes to the junction box. In between the various joints, we connect what we call junction diode, or sorry, what we call bypass diode. So the bypass diode works in a way that with any of the series connections in a particular row, okay, so the bypass diode is at the both ends, so that end and this end. If any of them gets interrupted, the series connection, because they are in series, if you break any line here, means the whole chain is broken. So to avoid that, bypass diodes are connected in between them, so that if any line is broken, the bypass diode will activate and isolate only that line. So we can, so let's say here is broken, it isolates only this line, then we can get our power from here and there. Okay, so usually with solar panel, we don't get the whole panel get disconnected, except you break each series line this way. If you break all of them, then if you break each series line this way, then it means finally you have isolated all the panel from the circuit. All right, and this, because we are doing the series connection, what it means is that the total voltage from this will be the summation of this, that, this, and that one. So when you add them together, that's what you're going to get. But remember, this is open circuit, it's not on load. Okay, this is when you have the highest resistance. So when you connect it to load, the voltage will now drop to the maximum operating voltage. Okay, good. So let's get started with our experiment and see what happens when